Hi everyone. The purpose of this video is to help you with graphing piecewise functions and then also to show you how to do this on Aleks. So we're given this piecewise function and it has two pieces. And what I recommend you doing is to get a piece of graph paper and actually graph this out on paper first by hand before you try to transfer your graph onto Aleks. So that's how I'm going to do this. I'm going to demonstrate how to graph it by hand here first, and then I'll use the Aleks tools to help you graph it within Aleks. So we have f of x is equal to x minus 4. So that's what I would consider my first piece. And remember, that's really y equals x minus 4. And that's going to just be a line. And we know that, remember, we can recognize it's really in y equals mx plus b form. So we can see that our slope, which is the m value, is 1, or 1 over 1, and our y-intercept is negative 4. So to graph this by hand, we would be going down to negative 4 on the y-axis, and then our slope, which is positive 1, means we're going to either be going up 1 and right 1. So I would go from that point up 1 and right 1 and continue doing that repetitively, up 1 and right 1. Or remember, to get a slope of positive 1, we could also consider that negative 1 divided by negative 1, because that is also equal to positive 1, which would mean we could also go down 1 and left 1. So from the y-intercept of negative 4, if I went down 1 and left 1, and I continued that pattern, I would get some additional points. So this is the entire line, y equals x minus 4. Now next we move on to the domain restriction, because it says we don't want the entire line, we only want the piece where x is less than 2. So there's two ways of determining which piece you want. One way is to look at your graph and go to the point where x is equal to 2. So I'm changing my color here in blue. You can see that x is equal to 2 right here at this point. Draw an arrow, that's the point where x is equal to 2, and that's the point 2 comma negative 2. And in terms of Aleks, we call that like our cut point. So that's the point where we're cutting our curve, and then we're going to either choose the portion of this line that lies to the left or the portion of this line that lies to the right of x equals 2. Now, because our domain restriction says we want x to be less than 2, that means I'm going to pick all of the x values that are less than 2, and on the graph, that would be the portion of this line that lies to the left of x equals 2. And that basically means I will be keeping this portion of the line that lies to the left, and I will be erasing the rest of it. So I'm getting out my erasing tool here, and I'm going to go ahead and erase the rest of that line. So I'm keeping that portion of the line. And then I also see that its x is less than 2, not equal to. So that would mean I'm going to want an open dot there, because I do not want to include x equals 2. I only want the x values less than 2. Now, that's how you could do that graphically. The other way of determining that point where we have the open dot is to actually substitute 2 into the function. So if I substitute 2 into the function, that's going to be 2 minus 4, which is equal to negative 2. So that means that the point on the line where we would have that open dot would be at 2 comma negative 2, which you can see does correspond to where we have the open dot on our graph. So that means now we are done with graphing the first piece, and we can move on to graphing the second piece of this function. So again, we have f of x is equal to, and this second piece is negative 2x plus 2. So I'm going to write that down below here. Y equals negative 2x plus 2. And that, again, is a line. So we know that our slope in this case is negative 2. You can put negative 2 over 1 if you want to. And our y-intercept is positive 2. So to graph this portion, again, on paper first, I would go to my y-intercept of positive 2. And then my slope, which is negative 2 over positive 1, that would be down 2 and right 1. So from the y-intercept, down 2 and right 1. And if we continue to do that repetitively, down 2 and right 1, down 2 and right 1, But again, remember, let me go back to the slope, that we could also treat this as 2 divided by -1. That is also a slope of -2. So if we have the positive 2 on top, that means I could also go up 2, and then the -1 would imply that I would go left 1. So from my y-intercept, I could also go up 2, left 1, up 2, left 1, and so on. And this would be, if I connected all of these, this would be the entire line. This is the whole line, y equals -2x plus 2. And now we look at the domain. I don't want the entire line. I only want the piece where x is greater than or equal to 2. So once again, if I look on the graph where x equals 2, I can see that point is right there. It happens to be an overlapping point where we had the open dot on the previous line. And then I want to keep the portion of this green line where the x values are greater than or equal to 2. And that means I am going to want to keep the right-hand portion of this line. So I'm going to graph that here in red, everything to the right of x equals 2. And because there is a greater than or equal to, it actually turns out that that solid dot will end up filling in the open dot we previously had at 2, -2. And then I'm going to erase the portion of the line here that lied to the left. So I'm getting rid of all these points that lie to the left. Get rid of that arrow. And let me make sure that shows clearly that that's a solid dot again. Solid dot right here at 2, -2. And again, another way of figuring out that solid dot is taking 2 and plugging it into that function right there. So if I did plug that in, that would be -2 times 2 plus 2, which is -4 plus 2, which is -2. So then you could see that you have a point when x equals 2, y equals -2, and that would be the point where this line begins, essentially. So once you have it graphed by hand and have an idea of what this looks like, then I think it's far easier to use the Aleks tools to graph this. So let me go ahead and clear out all of my drawing, and I will switch over now to the Aleks tools. So because it's a portion of a line, it's not a line segment. We don't have a beginning and an end point. We have a beginning point on this line, and then this line does go forever. We're going to use this tool here, which is the ray tool. We'll place our first point, and remember that open dot we said was at 2, -2, so that's the first point. And then the first line had a slope of +1, so we would have to go down 1 and left 1 to place my second point, because this was the portion of the line that we wanted. Everything that was to the left of x equals 2, that means values smaller than x equals 2. And then we would originally have thought that it was an open dot, so you probably would start with something like that. Then for the second line, we actually found that there was an overlap, so we'll choose that same tool. This is a ray, we call that a ray. And our first point is the overlap right there. And then our slope here was -2, so the second point would go down 2 and right 1, and that's how we get a nice slope of -2 for the second line. And then we realized because of the greater than or equal to, that we actually would have to come in here and change the open dot to a closed dot. So once we have it graphed, we answer the question, is the function continuous? And you can see that, yes, I could go ahead and travel along this graph, and I would never have to pick up my pencil. I could graph the entire function without picking up my pencil. So we would say, yes, this function is continuous before we check. So again, I really recommend that you graph it by hand first on a piece of paper. That seems to help most of my students then transfer their graph onto the Aleks site and have that happen a little bit more successfully.